welcome to the video on Avogadro's law. Avogadro's law really has two parts. The first part is somewhat common sense if you think about it. So the law states that when pressure and temperature are constant, the volume of a gas is proportional to the number of moles present. Okay, so if you think about it, if you increase the moles, that means you increase the amount, then the volume increases. So to me, that's pretty common sense. So not really enough scientific knowledge to really become a law. Okay, but Avogadro's law has two parts. Okay, and so this one to me is pretty straightforward. So if you increase the moles, then you increase volume. So as something gets bigger, it takes up more volume. Okay, and we all know that. Okay, and so there's a direct relationship. If you decrease the moles of something, then of a gas, then the volume also decreases. So it makes sense. If you have more, volume gets bigger. If you have less, volume gets smaller. Just pretty much like anything. So if you see here, if we increase the moles, so we start with just 1 mole, and we go to 2 moles, then the volume gets bigger. So we start with 1 liter and 1 mole, it goes to 2 moles and 2 liters. So the more moles, then the more volume we have. And we can directly relate these by V1 over N1 equals V2 over N2. And N stands for number of moles. Okay, and so we could, if we had a problem to solve, we could plug in our initial volume into V1. Okay, and 1 stands for initials, 2 are finals, and then you could just solve that way. But more importantly, Avogadro's law has another part to it. Okay, and before we discuss it, we need to understand what STP stands for: standard, temperature, and pressure. So STP stands for standard, temperature, and pressure. So often amounts of gases are compared at STP, meaning standard conditions. Okay, STP conditions are 1 atm, which is equal to the same if you look back at your conversions. 1 atm is the same thing as 760 millimeters mercury or torr. Okay, so that's your standard pressure is 1 atm, and 273 Kelvin. Okay, so that's 0 degrees C, but we know we have to use Kelvin when we are plugging into gas law equations. Okay, so at STP, we can compare moles and we can compare volumes and pressures and lots of other things. Okay, but at STP, okay, that means 1 atm and 273 K. 1 mole of any gas, so it has to be an ideal gas, meaning it behaves ideally, as we've talked about with gases. It has to be an ideal gas, but if it is at STP, 1 atm and 273 K, then 1 mole of any gas, so it doesn't matter what that gas is, it has a volume of 22.4 liters. This is what is very unique, okay, because we have not been able to say anything have a common relationship for solids or liquids that looks like this to relate moles and volume. Okay, so 1 mole of any gas is equal to 22.4 liters. Okay, so we have a new conversion factor. Okay, this is called the standard molar volume. So that's a number you need to memorize: 22.4 liters per mole of any gas. So let's put this in perspective. So here we have a mole of nitrogen and a mole of helium. Okay, so we could have a mole argon, krypton, whatever the gas might be. Okay, it doesn't matter, but if you have 1 mole of it, of course you have a different mass because nitrogen has a different mass than helium, right? Okay, but we have 6.02 times 10 to the 23rd particles. Okay, we know that because Avogadro's number says 1 mole is equal to 6.02 times 10 to the 23rd. Now, if we're looking at dealing with gases, this means for every mole, that gas is going to take up 22.4 liters. Okay, so that is unique for gases. So how can we use standard molar volume? Well, what is really nice about this is if we think about our new conversion factor, so for every 1 mole, we have 22.4 liters, we can relate moles to volume. Okay, that is very unique. So remember, like density equals grams per milliliter. That was unique because it relates grams and milliliters, so a mass and a volume quantity. Here we're relating moles and liters. Okay, so if we have a gas, here it's nitrogen, at STP, okay, it has to be at STP for this to work. Okay, if we know the volume, then we can find the moles. So here we have 2 liters of nitrogen, and we want to know how many moles of this do we have. So as always, we have to know our conversion factor, 22.4 liters per mole, or flip it over depending on how we want our units to cancel. Okay, so we're going to have to use this one for our units to cancel. Okay, so we write out what we know. This is above. Okay, we start all of our converting like this. Liters have to cancel, so we put 22.4 liters per 1 mole. So we picked this one here because liters has to be in the denominator for those to cancel. And this is moles of nitrogen. Okay, it could be any gas. That's what's so unique about this law, is that it's always 1 mole for every 22.4 liters of any gas. So if we divide 2.0 by 22.4, we get 0.089 moles of nitrogen as our answer. All right, another spin-off to this. So say you were given grams. We know that grams and moles are not the same. So all you would have to do is convert from grams to moles first. Okay, and so we know to convert from grams to moles, we divide by the molar mass. So if you were given grams, you would take that mass and divide by the molar mass. Molar mass is where we go to the periodic table and we add up the atomic weights for the compound or for the gas or the element, and we divide by that molar mass to give us moles. And then you would just do this same exact step. So once you got to moles, then we could go to liters. And to get from moles to liters, we are going to use our standard molar volume. Okay, so there's some variations to this, but it's really all based upon this conversion factor here. And then of course it can be plugged in either way, this way or this way, depending on what you're canceling and what the problem is asking for. All right, I hope this helps.